problem number 4, which is 3219. I have an R, I have an L, I have a C, I have E0 cosine omega t. 300 ohms, 0.25 Henry, 8 times 10 to the minus 6 farad, 120 volts, 400 radians per second. Forget the transient, we'll only look at the steady state solution. I equals I0 cosine omega t minus phi, and the tangent of phi equals omega L minus 1 over omega c divided by R. I think it's the third time that you see this now. It's interesting to write down the reactance of the 3 components. It's 312 ohms for the capacitor, it's 100 ohms for the self-inductance, and it is 300 ohms for the resistor. And so since Z equals the square root of omega L minus omega C squared plus R squared, you can immediately calculate that this is 367 ohms. And since I0 equals E0 divided by Z, you'll find that this is 0.327 amperes. And you find that phi, is minus 35 degrees. So the current is ahead of the driving voltage. Because if phi is negative, then minus phi is positive, so the current is ahead of the driving voltage. That should not surprise you, because the capacitor is more potent than the self-inductor. If the self-inductor was more potent, it would have the option, not the option, but it would have the capability of delaying the current. But if the capacitor is in charge, it puts the current ahead, and that's exactly what you will see. The current is ahead of the driving voltage. If we now put voltmeters over the R, C, and the L, then you're being told that those voltmeters, VR, as I have drawn them before, VC and VL, there's no sense of drawing them again. They are voltmeters, that they now only show amplitudes. So all phase information is lost. You don't see them shake back and forth with frequency omega. There is no phase information. All they will indicate is the amplitude. If they could show the instantaneous values, V at any moment in time, then you would see when VR is a maximum, and I repeat myself because I've said it before, then VL would be 0, and then V of C would be 0, the voltmeter over the capacitor. And when VR were 0, that means when I is 0, VL would read a maximum value, and so would VC would also read a maximum value, even though these two would be 180 degrees out of phase. All that is lost here. These voltmeters are designed in such a way that all they record are amplitudes. So the amplitude of the voltmeter over the capacitor equals I0 times the reactance of the capacitor. The voltmeter over the resistor would read I0 times R, and the amplitude of the voltmeter over the self-inductance would read I0 times omega L. But again, I repeat myself, at the risk of boring you, that these values do not occur simultaneously. It is more common when we deal with alternating currents to have voltmeters that express not the amplitude of the voltage, but the root mean square, which is simply the amplitude divided by the square root of 2. There's nothing very sacred about that. So if you wanted in this particular problem to convert the values to RMS values, all you would have to do is divide them by the square root of 2. And there is nothing more to it than that.